So, Hellier Maths students, here's an example which will hopefully help you with one of the tasks on the Introductory Project, and it involves somebody tiling a bathroom. Now, you may have been involved in a project at home, some sort of a renovation or home improvement task, so you may have some experience with something like this and feel that you could go ahead and pause the video and try and solve this on your own before I do. So if you'd like to do that, go ahead. Otherwise, I'm going to solve the problem. Now, with this one, I've gone and converted, so I've got the room here and I've converted these lengths in metres into millimetres. So 2.5 metres, is 2,500 millimetres. So you'll recall from previous video how to convert units of measurement. 3.15 metres, 3,150 millimetres. Okay, so two ways of approaching this problem. First is to consider rows and columns. Now if I was to go horizontally along here and I wanted to figure out how many tiles I would need in a row this way, blah blah blah, well I could divide that length that way by the length of each tile, which is 200 millimetres, and that would give me 12.5. And in a similar fashion, if I was to go vertically downwards, I could just figure out how many I'd need to do vertically, and because they're square tiles, it's the same length. Divide that by 200 millimetres, and that gives me 15.75 tiles. Now, here's an interesting question, and you might know more about this than I do, but obviously they're going to need to cut the tiles to get them to fit, because 12, for instance, horizontally 12 tiles won't be enough, but 13 will be too many, so they're going to have to cut tiles in half to get them to fit down this side here. And for the 15.75, they're going to need a three-quarters of a tile to fit in the last bit, so a full tile won't fit in the last two parts. So, this could get complicated if you really examine the situation, and you might come up with a better answer than I do, and I'd be very interested to hear it if you do, what your thoughts are on whether I've solved this correctly. But I'm going to go through thinking two ways here. I'm going to think, okay, let's buy plenty of tiles so that we know that we've got plenty and we can get home and just cut some. Assuming that the shop wouldn't cut them for us. They'd expect us to cut our own tiles. So let's say we actually need 13 horizontally and 16 vertically. So 13 by 16 gives us 208 tiles. Now, perhaps that's too many. Maybe you would say, well, you could buy fewer tiles than that. Let's say that we just did 12.5 by 15.75. Well, that gives us this number. So maybe we could buy, well, you can't buy 0.87 of a tile, but maybe you can buy 197 tiles and go home and cut some of the tiles up and get them to fit that way. But I think there's an issue there, because some of the tiles that you would buy and take home, you would need to cut into halves, and others you would need to cut into 3/4. So maybe you could look at it like this. You could say, okay, we need 196. We need 12 by 15, which is 180, right? And that'll fill up, all the bits bar the part I'll just rub this out and redraw it and show you what I mean. Bear with me a second. So I'll just reconstruct the edges of the room. So the 180 tiles there, that would fill up to here where you need another half a tile in this bit, and up to there where you need 3/4 of a tile in that bit. So here you'd have your 180 tiles, and let's see, we'd need another 13 down that way. No, it's beg your pardon, 16 this way because it's 16 tiles wide, and 13 this way. So that gives us 209 tiles. Okay, so there's one way of looking at the problem. Probably don't need that 209 tiles because we've got that overlap in there. So probably is still 208 tiles when we add the 180 plus 13 plus 16, but we don't really, because we've got that overlap, we probably only need 208 tiles after all. Okay, so that's one way of looking at it. You may disagree with that, and I'd love to hear your thoughts on it if you do disagree. But I'm going to say the answer is 208 tiles. Okay, and I hope that wasn't too confusing. So get me over and talk to me in person about it if you're not sure. What about if we were to divide areas instead? Okay, so we took the total area of the room and we divided it by the area of a tile. Okay, just one tile, not tiles, just one tile. Right, so the area of the room, we have 2,500 by 3,150. So that's the formula for working out the area of a rectangular room, length by width. And we'll divide this by the area of the tile, which is 200 by 200. These are squares, so same as a rectangle, length by width. Now if we do this calculation, well, we get 196.875 tiles, which is what we had over here. Matches up. I think the problem with this second method is that it doesn't take into account that the fact that we need those half tiles and those 3/4 tiles. And assuming that the tile shop won't cut the tiles for us, and also given the fact that we need to cut some tiles in half and some into 3/4 of a tile, I think that the first method is a better method because it takes that into account. But as I said before, if you disagree with that, you have some other thoughts, please discuss them with me. So as usual, the questions that you guys are going to try are in the description for the video, and we'll have a go at those questions to prepare us for the introductory project.